back everybody. This is part 2 of the RPG that we're going to be making. I'm going to show you today how to make this animated sprite character. Obviously this is Link from the Legend of Zelda. We're going to be going through how to manipulate a sprite sheet, how to add animation to it, how to kind of add an idle animation to it, and this will be kind of the first stepping stone into getting our game running. So we'll just do the movements today, and then we'll be doing the text in another video. But yeah, let's get going. Okay, so it is super simple how we're going to be looking at this. I'm just going to show you the sprite sheet that we're using so you kind of get a feel for how it is. This top row here, these are all the walking away from us. We've got basically walking up, down, right, left, and then this bottom section are all the idle animations. So we've basically got kind of like the idle animation that goes with this direction when we're in this direction, and so on and so on. So they kind of all coordinate the same thing. When we're thinking about this, we need to be thinking about how we're drawing these sprites. So we're drawing these sprites from this top corner here. So this sprite's position is going to be 0 on the x-axis and 0 on the y-axis. Then to draw the next position, the y-axis is still going to be 0, but we're going to increment it by the width of the sprite. So this sprite is 80 pixels wide. So we basically increment it by 80, 80, 80, 80, 80, 80, 80 until we get to the end, and then it goes back to the beginning here, and it does the same thing again. So it's like a flick book flicking through them all. Now, depending on which key is being pressed will depend on which line we're looking at here. So that's the y-axis, isn't it? This line here. So if we press the up key, basically the position we want is going to be 0. So we're going to do y times 0 is going to be also 160 80, because that's the height, times 0. Okay, so that's going to get us our y at 0 position. If we press the down key, it's going to flip onto this one here, and that's going to be 1 times 80, and then our state here is 1. It's going to go all the way through there. And then this is going to be line 2, so that'll be 2 times 80, 3 times 80, and so on. So I'll explain how that works in more detail in a minute, but we just kind of need to get our heads around why we're doing it. So it's this idea of we're just creating a rectangle and we're manipulating where the rectangle goes. It's constantly going across to create that animation, and then depending on our keystrokes will depend on which row it picks, and then it goes across from that row and so on. So how do we do that? Enough talking. How do we do that? So I'm in our RPG game that we made, where we made the tile map, because we're going to kind of build that from here. I'm going to create a player class. And good start. So we're going to create a player class here, and we're going to do our init again, and we're going to do our super as well. So the arguments that the player is going to take a character sprite sheet. You can shorten that down if you like. I just like to make it as obvious as possible for myself when I'm rereading back my code what the arguments are. We're going to do super, and we're going to initialize that just like before. And like I say, every time if you want to know a little bit more about what super does, have a little look around and you will find loads of stuff on about it. We're going to start off with an X and a Y position, so self.x and self.y, and we are going to do our height and width of the sprite. So I have created this sprite sheet to be each image on that sprite sheet is 80 pixels tall by 80 pixels wide. So I have created each sprite on this sprite sheet to be 80 pixels tall by 80 pixels wide. If you have a different sprite sheet, you're going to put different numbers in here, and you're going to iterate through that sprite sheet using those numbers. So here our height, mine's 80, and my width is going to also be 80. The speed is going to look at the speed that we're moving at. So I've messed around with this because it's based on the speed that we want to update, and it's based on the FPS that we kind of look at as well. So it works with the two there. We're also going to do a self dot frame, and we always want to be starting at the first frame. So in this sprite sheet here, we always want to be starting at frame 0. So we're going to start here and go from there. And then we are going to do this as well. So we're going to create a little buffer. So we've done this because on the sprite sheet, you can see this sprite here actually has all of this space around it. Okay, has all of this dead space around it. Now, really, when I made this sprite sheet, I should have made it so there was no dead space around it, and each of the sprites were actually bunched up right close to each other. But you will probably get a sprite sheet like this off the internet, which has all of this space around it. So what I have done is I've created a buffer, which will basically mean that when we create our sprite, we create it closer to this. It's still going to go exactly over our sprites, but instead of loading in all of this dead space here, which will mess with our collisions and it will mess with us getting close to the edges of the screen and things like that, we're just going to load in just this part of it here. So that's why we've got a buffer of 15. I'm basically going to take 15 pixels off each side of the sprite to get that working. You may find that you need a different buffer, so that's just something to have a little look at. And then we're going to load in the sprite sheet. I need to make these arguments smaller. So that loads in a character sprite sheet, so the one we pass it here when we actually create our player. So this means you can create multiple players with different sprite sheets, and you can kind of load them in and have them be controlled with different keys and things like that. And the image here, so this is the thing, this is the little square which is going to be loading the specific image that we want. And we are going to, so this is how we do it. So we do self.image, and it's going to be equal to self.spritesheet, and then it's going to be, so subsurface is a way of basically making drawable rectangles, or rectangles we can draw onto, and if we make a subsurface we can draw over them over and over and over again. So if you think about this sprite sheet as a flick book, we want to create one rectangle that we can draw over and over and over again to create the motion. So we do that with this subsurface. We were able to actually draw over the top of what we've got in there. And the subsurface is going to be a rectangle, and it's going to start at the X position and the Y position given, and it's going to be the width and the height of what we've just done. So self.width and then self.height. So I'll use that buffer in a minute to take off when we start drawing and things like that. So those are all of the attributes of our player. Now we're going to create a method which allows us to update the position. So we're going to call it update position. So in order to update the position, we do need to add some stuff into the top of this, but we're actually going to do the bottom of it first of all, because it makes more sense to do it that way. So we're going to get the keys which are being pressed, and they're going to equal pygame.get key pressed. So got key dot get underscore pressed. So this is going to return whichever keys are being pressed. Now I need to make sure that I don't go off the screen for this first bit here, because I haven't just really decided how I'm going to load in off-screen items and things like that, or different parts of the level. So for the minute, if the self.y, so the y-axis, is greater than 0, so basically I can't go off the top of the screen, I'm going to check the following. So if the up key is pressed, so if the pressed underscore keys is equal to key up, so key underscore up, then what I'm going to do is I'm going to increment the y by the speed which I've set. So this is how quickly my link character is going to move, and I'm going to set the state to 0. So self.y to minus self.speed. So if I think about me, if my y is 100 and I'm down the bottom of the screen here, if I'm moving up, if at the top of the screen is 0, I need to minus my speed. So I keep needing to minus 8 in order to move up. If I need to move down the screen, I'm going to plus the speed to it. I'm also going to change the state that I'm in to 1. No, I'm not going to change it to 0. So 0 is this top line. So if I'm moving up, I want my rectangle to be in position 0 here on this line here, is what I'm saying here. In a minute, if I'm moving down, I'm going to change that states to 1. If I'm moving right, I'm going to change it to 2, and so on and so on. So I'm actually going to very quickly put those together now, and I'll explain it in a sec. Okay, so these next ones here are looking at the other states. Just very quickly explain them. This again is this is the top of the screen. So these kind of buffers here, I've just worked it out so that my character can't go off the bottom of the screen. So this is basically the lowest it can go. On the right hand side of the screen, this is the furthest right it can go. On the left hand side of the screen, I don't want my character to go any more than kind of 3. Minus 3, because if you remember, I've got like this kind of box around my character, so I kind of, instead of wanting them all on the screen, like the whole thing of them on the screen here, I can kind of say, okay, we can lose a little bit of them on the screen, but we're going to mess around with the buffer on that anyway. So these 4 conditions here are up, down, right and left, and as you can see, the state changes in each one. So I've got 0, 1, 2 and 3, as I've just said again. So 0 is the top row, 1, 2 and 3 here. Okay, now we also need to have a look at this bottom row. If I'm not moving, basically I need to select this row. So if my state is 0 but I'm not moving, I want to go to that idle animation, so that is going to be row 5. So the way I'm going to do that is in this update position, I'm going to do a couple of other just if statements. So if self.state is ever equal to 0, and we can infer from this, as it's happening first of all, that the keys aren't being pressed, then we're going to change to row 4. So change the state to 4. So basically, if we're not pressing any keys, but our state was 0, instead of just running on the spot, we're going to move down to here, and we're going to idle on the spot, but still facing in the correct direction. And we do this again for all of the other states. So I've done it sequentially. So state 1, if it's equal to state 1, we're going to switch to state 5, and so on and so on for the other 4 states. That is it for that part of it. So all we need to do now is actually create the draw function. So the draw function's nice and straightforward. So actually, after I define our position here, we are just going to do def draw. Well, I say it's straightforward. It does take a few positional arguments. It's going to be the window and whichever keys are being pressed. Not 100% sure if I need those keys being pressed there. We'll have a look at that. We might need that in a second. So as we're drawing, we're going to be incrementing the amount of frames that are happening. So self.frame is going to be plusing 1 the whole time. If the self.frame is ever equal to 8, I'm going to reset it to 0. Self.frame equals 0. So this part of the draw loop actually draws the horizontal action, so the x action. So it goes from frame 1, 2, 3, 4, 5, 6, 7, 8, and if it's equal to 8, we reset it to 0, 0, and then we go around again. If it's ever equal to 8, it goes back to 0. Okay, so that's how we get this kind of animated effect happening. We're not quite, we still need to draw it, so that's just how we select the frames. So now we're going to actually draw that. So we're going to do self.image, and we're going to have to kind of, this is quite a long one. I'll explain it as we go. So self.image dot subsurface. So we're going to basically keep on drawing these subsurfaces, and that's a rectangle. Self.frame times the self.width. So I'll write a little bit out of this and I'll explain it, plus the buffer. Okay, so this is the x-axis here. So I'm going to do, if I'm at frame 0, the x-axis is going to be 0 times the width. So 0 times the width, so the width is 80, so 0 times 80 is going to be 0. And I add the buffer here. So that will select, not the whole of this, but just in a little bit from that. And then if I was on frame, as I go through, if I was on frame 1, it would be 1 times 80. So 1 times 80 would be this frame here. And then as I go round again, this draw loop, which keeps incrementing my frame, frame would be worth 2. So 2 times 80 would be here, 3 times 80 would be here, 4 times 80 would be here, and so on and so on. So you can see how we're drawing that animated loop. And we do the same thing for the y loop as well, so the y of it. So the state, self.state, is actually kind of defining where on the y-axis we're going to draw on that sprite sheet. So self.height plus the buffer again, so self.buffer. So bear in mind, you don't have to do the buffer. If you're just getting your head around this, you don't need to worry about the buffer for the time being, but it just takes the edges off of the sprite sheet there. So the state, so for example, if I'm going down, so if I'm pressing the down key, my state is 1. So with this draw loop here, my state would be 1 times the height of the sprite. So if I look here, 1 times the height of the sprite is 80, my 80 would actually start from here. So this is 80 down. If my state was 2, so if my state was 2 here, that would be 2 times 80. So that would be 2 times 80, so that would be 160. On the y-axis, 160 would start about here. So all the time, if my state is being defined by my keys here, then my x-axis is going to be chugging through, doing all of these, 1, 2, 3, 4, and so on and so on and so on. So that's how we're creating that kind of movement effect there, or kind of flickbook effect there. And then the last bit here is actually the sizings. So we're going to do, again, it's going to be the width of the sprite minus the buffer, and we are going to do the actual so I said the width of the height, no, the width minus the buffer, and then we're going to do the height minus the buffer as well. Blimey, that's a big one. And that is it. And we'll actually draw our rectangle for us. So that will get our rectangle and our image ready to be drawn. So all we need to do now is blit that to the window. So we're going to blit that. Self.image, and we're going to blit it at the x position, self.x and self.y. And that's it. Our function's all done. We are ready to go. We just need to put it into our main loop. So just before we add in our drawing to the main loop here, I'm just going to quickly remove this argument because we don't need it. We're not going to press keys to the draw function because we're not actually using it. I think maybe I was thinking about something different when I started programming that. So now in the main loop, all we're going to do is we're going to create link. So link equals player, and they take a sprite sheet. So the sprite sheet name that I made is this one here, and I'll put this in the GitHub for you guys to grab hold of as well, but you can load in obviously your own sprite sheets there. Make sure they're PNGs because then they'll have like blank backgrounds. And then what we then need to do is we need to, I've actually removed something else. This should have level.draw in here, so this actually updates the this updates the window, so that draws all the level for us. However, our actual link here, we need to draw a link as well. So we need a link dot update their position, and then we're going to draw them. So link dot draw, and we're going to draw them to the window. And if all is done correctly, that should now draw our little link sprite to the window. I forgot to write the state attribute, so I'm using it down here, but I actually don't have the state attribute. So self.state equals 0 to begin with. Yeah, because I do the frame and then I need the state as well. So I'll start at the top left of my sprite sheet. Let's try this again. So my whole draw function, I've actually included it within the update position function, so that needs to go back. So I'm going to highlight that and I'm going to dedent that region. So obviously that needed to be in line because it's its own function with update position. It's not part of update position. It could be, but we'll have it as a separate function now. So let's try it now. Oh, missed the comma. So after self.image, need a comma here because they're two separate arguments. We're getting there. We're nearly there, guys. This is the one. I can feel it. There we go. Oh, blimey, I'm a bit fast. But let's have a quick look here. I wonder why I'm going so fast there. That's very odd. I think it's because the frame rate is so much higher. So let's have a look at the frame rate here. Yeah, the FPS is set to 60. Let's take that down to about 15 or something. And let's hopefully Link will look like he's not having a seizure. There we go. That's looking a lot better there. So there we go. That's sort of animating and manipulating a sprite sheet. We can do our diagonals and things like that. We'll look at in the next video actually adding another sort of a set of animations to this, which can be different frame lengths, and then obviously because not all of our sort of attacks and things like that are going to be the same frame length, so we're going to look at actually how we would create functions to deal with attacks which have different frame lengths and things like that. So I hope you enjoyed that video and come back next time for the next one in the series.